Okay, let us continue for today's lecture. Yesterday we have seen the various formulas used in tachometry. Yesterday we have seen the formulas used in tachometry, that is when the line of sight is horizontal and when the line of sight inclined and when the staff is held vertically. Okay, so this is a numerical. Based on that, see here a numerical. A tachometer was set up at station C and the following readings were obtained on a staff held vertically. Here staff is held vertically. Okay, and this is the instrument station C. Here it is given that instrument is set up at station C, and here the two readings are taken. Stars are placed at two places, once at the benchmark and at point D. And here the angle of elevation is given. Here is a minus angle is given, means it is the angle of depression. It is given as a plus, means it is the angle of elevation. And these are the hair readings taken at the start with at benchmark and with the start with at point D. And here the RL of benchmark. The important thing is here you have to draw. The important thing is here that you have to draw here the diagram. Once you draw the correct diagram, your half problem is solved. Now see here. What idea you are getting here? Instrument station is C in the while taking both the readings, means this point C is between benchmark and point D. Okay, so here we can see here the one reading taken from the instrument station at C is minus, and another reading taken is the plus. Means we can easily say that our nature of ground will be like this. Okay, nature of ground will be like this, and our instrument station, that is station C, is in between these 2 points. One point is benchmark and another point is staff station D. Got it? Why I place instrument in between these 2 points? Because here it is given while taking both the readings, instrument is at the station C, means instrument is here midway between these 2 points, and why this benchmark point is below? Because it is angle of depression. And why this point is above? Because it is angle of elevation. Means this is the position of our tachometer, and from this position we have taken one angle of depression and another reading we have taken with the angle of elevation. And this is our instrument axis where it is the horizontal. Got it? This is our instrument station. Okay, we are set line of. Then we have taken the reading at benchmark with the angle of depression. With the angle of depression, that is theta. And what is this? It is a minus 5 degree, 20 minutes. Then again from station C, we have taken the reading stop at D with the angle of elevation. That angle of elevation is plus 8 degree, 12 minutes. Okay. Then next, what we have did? We have taken the upper crosshair reading and lower crosshair reading at these 2 points. Here also we have taken upper crosshair reading and lower crosshair reading. Means here at every stop we have to note 3 readings. We have noted 3 readings. That is upper crosshair reading, lower crosshair reading, and this is the middle crosshair reading. Here also upper crosshair reading, middle crosshair reading, and lower crosshair reading. Okay, so in the diagram, yesterday we have drawn, what we have taken this middle cross reading is nothing but the H height up to what? Up to point on the ground. Up to point on the ground. This is the ground level. And this H is nothing but the height up to ground. Okay. And here, what is H? H is this. And H is nothing but, what is H? H is nothing but the middle cross here. Reading. Means here, while we are seeing C to benchmark, what is the value of H? What is the middle cross here reading? It is 1.8. And here, what is the reading? It is the 1.5. This is nothing but value of H. Then we have to find out the staff intercept S here and staff intercept S here. Okay, so how can we get the staff intercept here? In case of benchmark, what is upper cross reading? Here if we take in a staff intercept as S1 for this case. How can we calculate it? It is the upper crosshair reading minus lower crosshair reading. Here three readings are given. You can always see that these readings are in the increasing order. Means first reading means the least reading is of lower crosshair, higher reading is of middle crosshair, and highest reading is of upper crosshair. So here staff intercept we can calculate by subtracting upper crosshair reading and lower crosshair reading. So here S1 we can calculate here like 2.450 minus 1.50. You can calculate it. It comes to be 0.95. Okay, 2.45 minus 1.5. Okay, so in this case, what is the value of S? Suppose we have taken it as a S2. So here, how do we get S2? Upper cross reading minus lower cross reading. That is S2 is equal to 2.25 minus 0.75. Okay, it will come around 1.5. Okay. Now, one thing is left in this diagram. What is V? Okay, and that is the important while calculating the RL. Now here V is nothing but distance between the position of this when our telescope is horizontal. That is this, and middle cross reading is. It is nothing but the V. Okay, is it visible? See, up to middle crosshair, and below middle crosshair, this is H. Okay, and here, what is the value of V? What is this is the horizontal position of our telescope is this, and this is the middle crosshair reading. So here the value of V, and this is the middle crosshair, and distance from our middle crosshair from the ground is given by H, and V is position of the axis of telescope in the horizontal position and in the inclined position. That is reading of middle crosshair. Okay. Did you get the diagram? What we have did? We have first decided the position of the tachometer from this given data. Okay. So from this we can easily see that the instrument station is C is for taking both the reading. Readings are taken from the same station, and while taking benchmark, it is negative, means this benchmark is below, and point D is at higher elevation. So we have taken point C here. D is higher elevation, benchmark at lower elevation. Okay, and all other things are same as I told you as yesterday. Here, Okay, did you get it? If you have any problem, you can write in the comment section. Okay, so the next thing is what we have to do, what we have to find out here. We have to find out the distance CD. Distance CD means this distance from point C to distance up to point D. This distance, horizontal distance. Okay, and RL of this point, RL of point D, we have to find it out. Okay, so first we will see how to calculate distance theta plus f plus d into cos theta. Okay, what is the formula to calculate this distance d? F by I into s. S is the staff intercept. Difference between upper Gaussian reading and lower Gaussian reading. We can calculate directly by subtracting 0.75.2.25. Okay, here we got staff intercept s, and we have the angle of elevation theta here, that is 8 degree 12 minutes. Okay, and what next we need? We need this value of this constant f by I and f plus d. It is given that the constants of instrument are 100 and 0.5. Okay, whenever constants are given like this, we have to take f by I as 100 because you know f by is nearly up to 100 and f plus d is in the some decimal. Okay, so here we can put up the value of this constant here. D is equal to f by I. What is the value for f by I? 100 into value s is 1.5 into cos square. What is the value of theta? 8 degree 12 minutes plus value of f plus d constant 0.15 into cos of theta cos of 8 degree 12 minutes. Okay, you can calculate it with the help of calculator, and I write here the final value. What is the answer we are getting? 147.090. Just cross check it. Okay. Then what the next thing we need? Now we got the distance CD.